right, well, let's do it here. Welcome, everybody. My name is Terry Baylog. I'm the founder and CEO of Frog Environmental. We've been in business here in California for 26 years. We do almost exclusively in industrial stormwater permitting. We have office and warehouse space in Signal Hill and in Berkeley. Right now, we have about over 1,000 customers that are under contract with us. And we are going to talk to you about Advanced BMP and the engineering assessment. So let's do it. We'll talk about the industrial general permit in the background, about level 1 and level 2. Advanced BMPs, what an engineering assessment is, the hydrologic calculations associated with it, the site visit, gaining control of the groundwater, and then what will the advanced BMP recommendation be. We'll discuss a sample, an example scenario, and then we'll talk about, once you get to the end of this process, what are the next steps. So, here in California, most of you are familiar with the Industrial General Permit. All comes under the Federal Clean Water Act. California devised their own stricter rules for industrial stormwater compliance. So the Industrial General Permit regulates stormwater from industrial facilities. Facilities must sample and analyze for applicable pollutants based on their SIC code. You know, if you're a metal recycler, you're going to be required to test for metals. And then if exceedances occur, your facilities enter level 1 or level 2 status for exceeding the parameters. What are level 1 and level 2 status? When a facility's stormwater samples exceed the IGP's NALs, the exceeding parameter is elevated into the next level status. So as we remember, we all start off baseline. We take our samples for the year. We average them together. We compare them to the NAL table. And if we exceed the NAL, then we go to level 1. While you're level 1, same thing. Take your samples, run the average. If you go over again, you become level 2. Whether you're level 1 or level 2, once you hit that status, a QISP must evaluate your facility and prepare an exceedance response action plans. These are always due January 1st. In order to return to baseline status after being level 1 or level 2, facilities must collect 4 consecutive clean samples that meet the IGP NALs. So you take your samples, you average them. If you're below, you drop back down. If you're above, you go to the next level. There's a lot of information on this table. This is kind of the timeline. I think it's most important to point out whether you are level 1 or level 2, July 1st, you enter your level 1 or your level 2 status. But it's real important once you hit that level 1 or level 2 status that first quarter from July to September, you decide what BMPs you're going to implement, and you implement those BMPs so that for the second quarter and we start sampling, we're ready. You know, get those BMPs, because then you go level 1 status, and then we implement our BMPs. We get a rain event in October. We get a rain event in November. We don't have any exceedances on those. Your ERA plan that's due January 1 starts to look really good. Here's what we implemented. Here's 2 samples that show how well or how good our BMPs have worked. So again, a lot of information here, but that first quarter, it's real important. And deciding on which BMPs you're going to implement is just as important. So once you become level 2, you have to do what are called advanced BMPs. As a baseline or level 1, you're required to do minimum BMPs. Once you become level 2, you're required to do advanced BMPs. Types of advanced BMPs, exposure minimization, covered area. You know, do you have an outdoor grinding area that you can cover? stormwater containment, some kind of a retention pond. You capture the certain amount of volume, and then you do something with it. Stormwater discharge reduction, infiltration, or redirecting. A lot of times, if you don't have industrial activities on your roof, you can redirect your roof water away from industrial areas. That's huge for a lot of places, because I see a lot of times where the roof areas come down through, industrial areas and just add to the problem. Other type of advanced BMP, treatment system, end of the pipe, pump it through a filter, get it down and release it. And then you have other BMPs that you can implement. So the engineering assessment, and what does that engineering assessment mean? An engineering assessment will assist the facility in identifying how to proceed with advanced BMPs. It is a roadmap for future upgrades to eliminate exceedances and stay in compliance. The engineering assessment includes the hydrologic calculations. So what is our volume? What is our volume of water that we have to deal with? Requires a site visit. We got to get out there and get a lay of the land and see exactly what's going on. And then a report with the advanced BMP recommendations. So who would need an engineering assessment? Facilities with sample results that significantly exceeded the benchmarks, NALs, the Numeric Action Limits. And please note, you could be level 1 or level 2. Sometimes you're a level 1, you may only be level 1, and you're thinking you got a couple of years before, you need to start planning. Because from our experience, some facilities, even if you're level 1, the minimum BMPs aren't going to be enough to meet the NALs. So even though you're not level 2 and you're not required it, you need to start planning, because it's a 99% chance you're going to end up level 2 anyways. The advanced BMPs, well, they're necessary to eliminate future exceedances and to significantly improve your sample results. We could talk all day about the liability. We know the stories. Level 1 and level 2 ERA designation, you're talking additional consulting fees, additional work, engineers. Increased scrutiny from both regulatory agencies and third-party environmental groups. We all know these third-party environmental groups now with smarts, they're going and looking at your results, looking at people's results, and if you have a history of exceedances, well, they threaten to sue you in federal court. They're really the enforcement. Although a lot of regional boards in the state are really starting to step it up. And here's the other part about the cost of advanced BMPs. These are what the exceedances lead to. So, we highly encourage you, don't be passive. Even if your results are high or not close, you got to keep doing what you're doing, because you're going to be on the hook for spending some money down the road in order to address this. Double slide here, my apologies. So the engineering assessment, the first part, the hydraulic calculations. We perform a hydraulic analysis to determine the volume of stormwater that the advanced BMP will need to be sized to capture or treat this water. We do this using local rainfall data, requirements listed in the IGP for hydrologic calculation, and site-specific conditions. We'll have some scenarios, we'll talk about what that means. But basically, how much water is it? What does an 85th percentile rain look like in my area? Is it 10,000 gallons or it's 200,000 gallons? That's really the first key step. And before the engineering assessment even begins, we want to know what volume that we're dealing with. And that gives us, and this volumes gives us the ability to calculate different scenarios. Examples of hydrologic calculations. So within the industrial stormwater permit, once you become level 2, there's two ways. You look at volume-based treatment or flow-based. Volume-based would be example calculations to find the total stormwater volume for an 85th percentile 24-hour storm. So here's a facility, it's roughly an acre. Our runoff coefficients, that has to do with how much water runs off a given surface. And then here's our rainfall depth that we calculated. And then we run all these scenarios, and under your volume based, you come up with 17,000 gallons in this particular scenario for a 1 acre facility. 17,000 gallons, as you roughly know, it's a fair amount of water. You've seen the big Baker tanks. I believe that there are 40 feet by 8 feet by 8 feet. That's about 20,000 gallons. The second type of calculation we use would be the flow based, and that's to find the peak 1 hour stormwater flow for the 85th percentile 24-hour storm event. So this one, the first one, you're dealing with the volume of water. The second scenario is you just deal with a flow of water. So here's the same site, about an acre, runoff coefficients. You have to add a safety factor in of 2. And then you have your rainfall intensity per hour, and that in turn will give us a GPM. So for this same facility, you're at 121 gallons per minute of flow, or 17,000 gallons to treat. So it just depends on the way you go with the calculation. Is if you don't have enough room, will you go with the flow based? But if you have room to store water, well, then you consider the volume based. Again, this all just gives us an idea. We prepare it both ways so that both scenarios can be considered as part of the engineering assessments. And it's interesting to note that these rainfall depths can vary differently in areas, or just, if you use 2 different weather stations that are 5 miles apart, they can have incredibly different volumes. So that's something to consider in the amount in the calculations as well. So now we've done our hydrologic calculations. Well, now it's time for the site visit. The site visit is to determine, what are we going to have to do to get control of the water? Is the water flowing to 5 points? Are we better off doing something at all 5 points? Or do we capture all 5 points and bring it to a single point and do something there? That's all part of considering, how do we get control of the water? It's the single most important thing. Once we get control of the water, there's a lot of different things we can do with it, but getting control of the water first and being able to prove that you get control of that volume of water that you have to is key. And that's all used to determine the appropriate BMP to consider and where to install it. Again, something at each individual point, or combine them into one. And there can be one or several recommendations. When we do an engineering assessment, we like to give at least 2, minimum 2. We like to get 3. It's not always that easy. It's not always that capable of that, but we like to give different scenarios. The site visit, we also identify the pollutant sources. Again, even though we're looking to do some advanced BMP, to do something, if we can go back and start considering redirecting water from non-industrial areas away from these pollutant sources. So again, we consider the pollutant source. That's all part of the site visit. So how do we get control of the water? Decide where on the site the advanced BMP based on flow and industrial. How do we direct it to the proposed BMP? And then we identify if non-industrial runoff can be directed away from the industrial runoff. I've covered this a little bit already, but again, it's, where's the BMP? What's the BMP? How do we direct the water over there? Can we redirect all these other things? So then once we do that site visit, that's the kind of information, that's the most important step, is getting control of the water. Even if you don't move ahead or do an engineering assessment on your own, when you're out walking your facility, you should absolutely be considering how to get this to control this water and what you can do. And one thing to consider is water storage, isn't always cheap. So just grabbing the water and storing it, once we store it, we've still got to do something with it. So these are all things to consider. Third step in this is, what's the advanced BMP recommendations? So here we go. We've done the hydraulic calculations. We've visited the site, and now, well, a report's generated that will make one or several advanced BMP recommendation. This report is used as a roadmap to eliminate the exceedances in the future. Even if you're not ready, either financially or interrupting production or whatever happens, even if you're not ready to start implementing an advanced BMP for whatever the scenario, at least you have this report that tells you exactly what you need to do so you can start putting it in. Some of these jobs, we have some jobs that are done and planned in 3 months. Other ones, after the engineering assessment, it could be 2 years before the decision's made and what makes the most sense. So this report's just the start of it. So now let's talk about an example scenario. This is the facility that we chose is a metal fabricating facility, 1.5 acres. Their exceedances are aluminum, iron, zinc, nitrate plus nitrite, total nitrogen. So pretty typical. This sounds like your pretty typical metal fabricator, some grinding, some cutting. The nitrate could be from the nitric acid as rust inhibitors. All of these things, either way, here they are. So currently the facility in this scenario, here's the facility border. This facility has 2 outfalls, DP number 1, DP number 2. Both points were exceeding, so it's a question of, okay, are we better off doing something at one point or both points? As a result of our site visit and everything else, well, what we discovered on the next slide is it's getting the water over to one point. For this particular facility, you can see how crowded in they are in this facility. There really was nowhere to do water storage for both of these points. So their best bet was get a hold of all the water, push it over here to a single point, and then they did through their advanced BMP. That advanced BMP is treatment in this case. Sometimes the advanced BMP could be infiltration wells, other things, but in this case, it made the most sense to get the water to one point. So we've completed the engineering assessment. We've calculated your volumes. We've visited your site. We've made some recommendations. You're still taking samples. You're still having exceedances. Well, what next? Now is the time for the decision making. Which advanced BMP? First you think about the planning and permitting that goes involved. Some of these treatment systems that we install, depending on the city, again, you could be anywhere from 3 months. We're going through one in Southgate. It's been 1.5 years. And, the interesting part is going through this planning and permitting process in the city of Southgate is the hardest part is getting them an understanding of what we're trying to do. So when you go to them with this industrial stormwater and we need to do something, there's all these different scenarios. They'll try to hit you with the SUSUMP or the water quality management plans. Those are all based on new construction, so they don't really apply. Well, then the city will say, well, the LID, low impact development, and the low impact development doesn't always apply because it's not really new construction and you're not really doing enough to trigger those results. So a lot of times what we've discovered is the problem that you go through with the permitting process is cities don't have a place to plug in industrial stormwater. They understand construction, they understand municipal permitting, but they don't really have a box that industrial stormwater permits fit into permitting. And I think that's the problem in Southgate is they can't find who's in charge, what box this goes into. And that's what a lot of the discussion has been. So you plan and permit. Well, now it's time to start the installation. Sometimes the installation is very simple if you're at one point. But for, let's go back to our scenario here. This site here, This involved a lot of trenching. We had to build a pad. We had to install a new catch basin here, a new trench drain here. So there could be quite a bit, and in this scenario, you had trucks in and out of here all day long. The last thing that happens is not only is this stormwater equipment costing you money, and it's not actually an item, it's not like buying a baler or a new computer, something that you get your return on investment. You don't really get a return on investment other than you're complying. And in this scenario here, it interrupted production. I mean, we were up there after hours and on weekends because they literally had 30 to 50 trucks coming in and out of here on a daily basis. So, interrupting production is a big consideration for all of this. Timeline for the project completion: new level 1, new level 2, continuing level 2 or technical report. So that's all. You have these exceedances as you become a level 1. Well, knowing that we could be up to a year or 2 years permitting and planning, if you're a level 1 that's not even close, meaning you're over 30% over your limit, you need to start that process now, or you're going to hit level 2 and then start the process. And then once you're level 2, you only have a certain amount of time. It's either, I think it's up to a year to implement your advanced BMP. So, you're really opening yourselves for liability, because not only are you level 2, but you weren't planning on level 2. So you're behind the ball here. Regional board and all of that, they're going to step up enforcement, plus these level 2. The main thing to consider here is cost. What can we do? Not everybody has, a lot of money to spend on treatment. Well, if we can go, as long as our plan, our level 1s and level 2s, we have some timeline. Okay, this first year, we put it in the budget to get all the water to one point. The next year, we, to put the first year, put all the water to one point and put the infrastructure in. Let's get some electric out there for the pump. Let's get the plumbing in the ground. Let's get control of that water, get it to a point, and then we're going to do something with it. And then our timeline says year 2, now we're going to install a tank to capture that water. And then that tank is going to be allowed to settle for discharges. And then maybe year 3, we start to look to add some medians, some vessels. As long as we don't have to do everything right now this minute, and we can, the level 1s and level 2s allows us to establish timelines, but we have to stick to those timelines. And these third-party environmental groups, they absolutely do not stick to timelines. You have exceedances, they don't care where you're at or what you said, they want things done now. So that's why, again, it's important to get out in front of these things. So that is what we have for here. The only other part that I wanted to bring up is I wanted to talk a little bit about some of the liability and the expectations here. We've been at this a long time. All over the state, we have seen a huge increase in lawsuits. And now the lawsuits used to be typically based on exceedances. Okay, we look back at your sample results, and every rain event for the last 3 years, you exceeded iron. So we assume every day in between, you're also out of compliance for iron. Now we're going to, drag you into federal court and fine you and make you miserable, or we can sit down and we can talk about it. And that used to be the case. Now what these lawsuits are starting to do is they're starting to say, okay, you didn't sample 4 times last year. We see there was at least 8 qualifying rains. We're still going to slap a lawsuit on you because you're still not complying. So they're taking a whole new approach. It used to be based on exceedances. Now it's based on not getting the samples. They've also in these lawsuits started to say you're submitting results and not certifying them within the 30-day deadline. Down here in Los Angeles, regional board has just sent out a whole bunch of fines based on the 2021 year, people submitting uploading sample results and then not certifying them within 30 days. So there's a whole bunch of people that got fined for that in 2021. So that means, guess what? If you got you in 2021, they're going to get you in 21, 22. So if we can't take anything else away from this meeting, we also want you to make sure that you get in there with that 30-day deadline and certify those results. LA board's the only one doing it right now, but it's a slam dunk for enforcement. And you know, believe me, we've reached out and we've discussed it with them, made arguments, made that, and they basically have there is no reason for you not to submit those results. They said you could be on an island in the middle of nowhere, and if you have cell phone reception, you can certify results. So these rise in lawsuits and regional board enforcement, you know, these are the things to watch out for. And that's why if you are having exceedances, you know, you got to get proactive on these things. And the engineering assessment's a good place to start because it's something that everybody can sit and review together internally, whether you're in a corporate structure, a smaller structure, but it gives somebody to have a discussion about what needs to be done. And that's important is, you know, we've definitely got to move forward and make some decisions. So at this time, I don't really have anything else. Does anybody have any questions?
Yes, we have one question come in that said, once stormwater is stored, what is the turnaround time for the water to be treated in preparation to capture/store the next rain event, specifically for rain events that are continuous multiple days in a row?
So I believe within the general permit that it would be 48 hours that you have to be able to get rid of that water. I don't know the exact, maybe one of our people here, Frog, can bring me that information. But the problem with, you know, having that volume of water, so people make the scenario, okay, I've captured my 17,000 gallons of water, I'm good. But you're right, if it's getting ready to rain the next day, you got to do something with that water. So the volume based makes sense to us, but you still have to have some associated BMP with it, whether you're running that water through some kind of a filter bag, whether you have permission to dump it into sanitation, you know, but you have, I believe the time is 48 hours to do it, to get rid of that water. But we can correct that here in a minute.
Okay, fantastic. If you have any questions, feel free to unmute yourself and ask Terry, or you can put them in the chat. But while we're waiting for those to come in, thank you everyone for joining us. If you missed any part of this workshop, either you were late to join or you're having technical difficulties, it is being recorded and will be posted on our website in about 24 to 48 hours. So you can watch the entirety of it or share it with someone that you think would benefit from this information. So if there's not any final questions, then we might end early. Any closing thoughts, Terry?
Nope, just that you know, you definitely got to get on top of this. This is only getting stricter. These TMDLs that they have here in Los Angeles, that's another thing that people are getting fines for. These exceedances and not compliance. You know, it's just, you've got to do something, because the problem is once these third-party groups or regional board, they come in and do some kind of enforcement. So if you get sued, it's not even about what you're going to do moving forward. That's all retro. So before you can even make a decision about what you're going to do forward, you have to negotiate with these guys of what your penalty is for previous non-compliance. And then you have to agree about what you're going to do moving forward. You know, so that's the big thing about it, is once they got you, they got you. It's not about, hey, you're doing something wrong, let's talk about what you're doing forward. They said, hey, you're doing something wrong, here's a fine for that or a potential lawsuit for that. You know, now we got to talk about what you're going to do moving forward. And they hold you to a tight guideline. And these lawsuits will also say, okay, that's great, you're installing treatment in a year, but regional board's okay with your timeline, but the fact is, every time you have an exceedance, we're gonna ding you again. So that's the last thought I'll leave you with, is just getting out in front. And if you take nothing else away from this, really start to go out and look at your site and think about what you have to do to control that water.
Fantastic. Well, thank you so much, Terry, for presenting. We really appreciate it. So much great information. And thank you everyone for joining us.
All right. Thank you, everybody.